All right, so lesson 22, transformations of logarithmic functions. All right, so by now, this is probably, you guys are probably used to this, right? The same thing, the same equation, right? But where you've got like your A value, your B value, your H value, and your K value. So all based on the same thing. The only thing that's different now is that we just got that log, right? And that would be log of anything. So log base C, that's our original function, or base function that we're going to be using here. The logs are actually nice because it actually looks pretty intuitive. It almost looks exactly like the formula on your formula sheet, where this was just, f of, b x minus h, right? Like it was all written like that. It's very similar, so I don't think you guys will have a hard time with what to do. But let's go through a few examples. I think we can jump right into it to do these transformations. So this one says, sketch the graph of the following logarithmic function, state the domain, range, and equation of the asymptote, and x and y intercepts. All right, so what we want to do, we want to start off with our base function, right? So in order to apply these transformations, right, like I know that those are going to shift this thing around. I need to know what the original function of, well, just y is equal to log base 4 of x, right? That's kind of like my starting point. But it's not as nice as, like other ones where our base function, like in the other units, would have been something like y is equal to, let's say, well, I guess that'll be similar to our exponents part, but x squared or something like that, right? Or just x, and then you're changing it from there, like x squared or absolute value of x or something like that, where it would look the same every time. Or in the other unit we did, the base one was like the square root of x, and then we applied our transformations to that, but the square root of x always looked exactly the same. So you could kind of just memorize, like the way the original one was. With exponents and logs, we can't really just memorize it because the base is actually changing every time, right? So what we have to be able to do is draw out our just original base function of this, and then apply our transformations. So how do we draw out our base function of that? You could just start putting in numbers for x and seeing what you get out for y, but it's going to be hard to kind of guess which ones are going to give us nice numbers. So we end up like on a nice point there. If you start doing that, you're going to end up getting like a lot of decimals and stuff. It'll be a bit easier to think about this instead, if you remember from last lesson, as, well, let's rewrite this as an exponent. So this would be the same thing as, so base 4. So that's going to base, and then to the power of y is equal to x, right? That's the inverse of the exponential function. But now that it's written like that, I can actually quite quickly sketch this, right? Because if that's my original, you can make a table of values if you like, with like, your x and your y, but I think we'll be okay for now just to say, okay, well, let's start throwing some numbers in for y and getting some numbers out for x. So let's throw in an easy one. Let's throw 0 in for y. So that means along my y-axis, right, y would be 0. So if I threw a 0 in for that, that'd be 4 to the power of 0. That'd be 1. So when y is 0, x is 1. And if you remember, that's kind of like a telltale sign of a logarithmic function, right? That, exponential functions would have passed through 0, 1. Logarithmic functions pass through 1, 0, right? They're inverse of each other, right? So, okay, so I know that that's going to be a point on my base function. Now let's throw in 1, right? Throw 1 in for y. So when y is 1, then that'd be 4 to the power of 1, x would be 4. So when y is 1, x is 4. So that'd be right there. Okay. And now that's probably good enough to kind of get the gist of this thing, right? Because I know that this has a horizontal asymptote at, sorry, my graph's a little off there, like where that is, but horizontal asymptote coming up like so, right? And it would do something like that, where it would be approaching but never getting to 0, right? That's by like the standard. It has a vertical asymptote, I should have said, a vertical asymptote at x is equal to 0. Okay, so that's where we're starting. I could start throwing in numbers like, you know, when y is -1, well, then that should have been at like a quarter there, right? You could keep going all you like, but that's probably a good place to start. Okay, so now that we've drawn that graph, we need to do these things. So let's rewrite that a little different. Let's rewrite that as y is equal to log base 4, x plus 4, and then it's going to be -5, right? I just drew it a little bit more like, you know, the equation on your formula sheet there. Just brought the 5 over. Okay, so from that, I can see that this thing has a horizontal translation, right? Because of this, has a horizontal translation of 4 to the left. Okay, and it has a vertical translation of 5 down. You guys should hopefully be kind of used to that by now, right? Okay, so if that's the case, then really what we can do here, you can just take these points if you like, just that point that was there. Well, that thing is going to go 4 to the left, so 4 to the left, and then 5 down. So 4 to the left, and then 1, 2, 3, 4, 5, right? So they'd be there. So that point would now be there. Now this point that was, you know, right there, that point would go 4 to the left. So 1, 2, 3, 4, and then 1, 2, 3, 4. So that'd now be there. Okay. Did I skip one? No. Oh, my graph just looks different than your guys. Sorry. Like on my other one. Okay. So anyway, so that's the idea there. And then from this, I actually know too that, well, if our asymptote was at 0, which it doesn't look quite right, but if it was at x is equal to 0 there, if this whole thing shifted over 4, then that also definitely means that the asymptote of this guy would also be shifted over 4, right? That asymptote would be at, well, it'd be at -4 now, right? So we kind of have enough to go off of here. Yeah, 4 left, 5 down, 4 left. Oh yeah, sorry. So that's there now. Yeah, sorry. That was kind of screwing me up. Yeah, so we're down here. That's good. So now this would come up, right? Like it did before, and then pass through there. It was the colors that I made that screwed me up there. Okay, so that's our new graph, right? So you can do it that way, which is great. The other one that, especially when they start getting a little bit more confusing, that I would recommend doing is doing our mapping notation, right? So as soon as I have this information figured out, then what we could have done is said, okay, let's make our mapping notation of any point on the original graph x. Then if I took any point on there, then I can say that it would be x and then 4 to the left. So that'd be -4. And then my y values would all be y plus 5, right? So then once I have this like key made, then I can just, any point that was on the original function, I can just put it through this formula and then you'd be good to go and you can kind of sketch it out. Either one works, right? But I find, especially when you get like you know, stretches and reflections and everything else, it gets kind of hard to make the graphs, like all the intermediate graphs in between. It gets a little confusing of like, you know, which graph is which and like where you are now. So yeah, you can do that, but yeah, I like this way. But all right, so let's move on here. Why is that number 3? Something's going on here. Well, okay. No, that's right. Weird. All right. Just changed my numbering, I guess. Okay, so the next one. So we've got y is equal to negative, yada, yada, yada. So same thing here, guys. What I'd recommend, let's figure out what the graph, what the original just graph of y is equal to log base 2 of x, right? Let's write that down because that's like our starting point. And then we're going to apply our transformations after, okay? So let's sketch that one out. So again, it's kind of hard to tell what that would look like just looking at it right now. Let's rewrite that guy. Let's write it as 2 to the power of y is equal to x, right? Just rewriting that log as an exponent. And now I can start kind of sketching this one. So if I threw a 0 in for y, then that would be 2 to the power of 0, that'd be 1, right? So when y is 0, x is 1. And that really should always be the case, right? That first point. But now the second point, if I throw a 1 in for y, so if I throw 1 in for y, then I'd be at 2 to the power of 1. That'd be an x value of 2. And maybe one more. So let's throw a 2 into that one. So if I had 2 to the power of 2, that'd be 4. So when y is 2, x should be 4. All right, so that's probably good enough. I can sketch this guy because I know that this thing has a vertical asymptote at x is equal to 0. So, so this guy would do something like that. Okay, and I got these points as kind of references there now. Okay, so now that's my original function, or my base function. So now let's figure out what our transformations were here. So this negative out front, that's telling us something. That's telling us that we have a vertical reflection in the x-axis, which, remember, that just really means it's flipping over the x-axis, right? Vertical reflection. All of our y values are changing, right? Is what that's saying. So we got that going on. And then the other part, that looks like a b value to me, right? That's actually attached to the x. So then remember, that one's actually flipped upside down. That's different than you would think. That one is saying that we would have a horizontal stretch of a quarter, 1/4. Okay, so now let's try doing our points method instead, right? Because what we could do is we could do intermediate steps, right? I could stretch this thing by a quarter, right? And then I could flip it over the x-axis. They've actually worked to do it either way, right? And you could draw 2 graphs till you get to your final graph. That would work, right? To draw on your intermediate graphs. I'm going to do it all in one move, though. Let's make our mapping notation. So I'm going to say xy. Any point on xy is going to turn into. So then for the x's, that's going to be 1/4 x, or x divided by 4, same thing, comma, and then our y, this one's attached to the y, right? So this would be negative y. So any point on there, it's going to go through that, right? So let's just throw some points in it. So I know that this is a point, right? There's one of my points. So let's put that point in. So see where it ends up. So that point, that is 1, 0. All right, if I'm applying this to it, then that's going to be 1/4 times 1, comma, so that'd be my x value, and then my y value would be negative and then 1. So that point, here, maybe I'll just draw another arrow, do it over here. So that point would be at, okay, so that would be at 1/4 times 1 is still a quarter, and then comma, and then negative 1. Oh, sorry, that shouldn't have been 1. That should have been 0. Yeah, our y value was 0. 0. Okay, so then negative 0, still 0. Okay, so that's our first point. So this is a point on our graph, like 1/4, comma 0. So when x is a quarter, y is 0. So this point, that purple dot that I have there, that purple dot is now there, right at a quarter. All right, so let's see what else happens. So let's do another one. So let's take our point here, right? The point at 2, 1. Let's move that one. So that would be at 2, 1. So applying our transformation here, that would be 1/4 times 2, comma, and then negative, and then 1. Okay, just putting it into this. So then that would be the same thing as, so 2/4, that would be the same as a half, comma, negative 1. Okay, so then we'd have when x is a half, when x is a half, y is negative 1. So something like that. Okay, Let's do one more. I feel like, especially since this thing flipped upside down, I feel like I know the way this is going to look, but let's do one more just to make sure. So let's look at this point. The numbers will be a bit nicer now. Okay, so I'm looking at that point. That's at 4, 2. So the point at 4, 2 would now be at, so that'd be 1/4 times 4, and then negative, and then 2. So where does that one end up? So that's going to be at, well, 1/4 times 4, that's 1, comma, -2. Okay, so 1, comma, -2. So that point would now be at 1, comma, -2. So that's down there. And I got a good idea what's happening here now, right? Especially because this thing didn't have a horizontal translation, right? It didn't shift to the right or the left. So I know that this vertical asymptote is still the same, right? This line at, sorry, vertical asymptote at x is equal to 0 is still the same. That's not moving left or right. So that's going to still be there. So this graph would still be approaching 0, but it would look more like this now. And there you go. There's our new graph. All right, let's do it again. Practice makes perfect. All right, so looking at this guy, and again, let's do what we've been doing before. Let's just do our base function, right? So our base function here, let's graph that, would be y is equal to, and then just log base 3 of x, right? That's just like our starting point. Now, let's rewrite that again. So that would be the same thing as 3 to the power of y is equal to x. Okay, so we start graphing this. So again, let's do a really easy point. Let's make y 0, right? So when y is 0, x is 1. Or sorry, when y is 0, yeah, x is 1. So that's our point right there. That's always right there for our base function. Okay, so let's throw in 1. So when y is 1, x is 3. All right, so I pretty much have an idea there too, but if y is 2, it'd be 9. So if y is 2, I'd be at 8. So it'd be like over here. All right, but that's the idea. And I know this thing goes across the asymptote or approaches 0 there. And there you go. There's my base function. All right, so now let's rewrite this again too, because I'm not a big fan of the way it looks right now. So that would be the same as y is equal to 2 log base 3. And then here's where I don't really like the way this looks. Like, what's my b value there? I can't really see it very clearly. So I'm going to do this in 2 steps. I'm going to write this a little bit closer to the way I want to see it. That'd be the same thing as -x plus 3. Like I just swapped the 3 and the minus x around. Okay, but that still doesn't look quite right because remember, I got to see the b. So let's write it one more time. Let's write it as y is equal to 2 log base 3, and then I need to see the b there, right? So this is where I got to factor out the b out of this one. So what I'm going to do is I'm going to factor out like a -1 or just a negative, either one. So -1, and then you'd have a bracket, and then that'd be x minus 3 because I factored out the negative. Okay, so there's my b, right? It's -1 or just negative, and then plus 5. Okay, so we have everything we need to actually see our transformations here. So this thing has so first off, it has a vertical stretch of 2, right? Because of that one. We have a horizontal reflection in the x-axis, or sorry, in the y-axis. And that's because of this guy, right? That's our negative there, is just flipping that thing over the y-axis. All of your x values would change their signs, right? Okay, and then we've got a horizontal translation of 3 to the right. So horizontally, 3 to the right because of that one. And then a vertical translation of 5 up. Okay, so there's our pieces. Let's make a mapping rule out of this. So we'll say any point on this original function, I'm going to take all three of the points I graphed there. I'm going to graph those on the new one, right? But I'm going to filter it through my mapping notation first. So any point xy will be, okay, so horizontal reflection in the y-axis. So that's going to mean that's going to be negative x and then plus 3, right? That's what all my x values are going to do. And then my y values would have a vertical stretch of 2. So that'd be 2 times any of the y's. And then vertical translation of 5 up. So that'd be plus 5. So there we go. There's my key, right? Once you get this, it's pretty simple math from here, right? Like as long as you don't make a mistake, right? But from here, any point that was on that original, just put that point into this, and then we can figure out where it's going to be, where it'll be in the end. All right, so let's do a few now. So let's do the point. Let's do the point. Let's do this one. Okay, so the point 1, 0. So 1, 0, where's that going to be? Okay, so that'd be negative 1 plus 3, right? That's what the x will turn into in a second. And then my y value is going to be 2 times 0 plus 5. Okay, so this point is going to end up at, so just simplifying that, negative 1 plus 3 is 2. And then 2 times 0 is 0, and then 5, right? So that new point, so there's going to be a point at 2, 5. So at 2, 1, 2, 3, 4, 5. So this point there is now up there, okay? All right, let's do it again. So 3, let's do this one now. Shouldn't make them all the same color, should I? There, that's our new one. So it's going to be blue. So let's do this green one. We'll move that up and see, or we'll move that and see where we're at, right? So that point there, so we'll say 3, 1. So point 3, 1, where's that going to be? All right, so that's going to be negative 3 plus 3. And then our y value is going to be 2 times 1 plus 5. So that one will be at, okay, negative 3 plus 3, that's 0. And then 7. Okay, so 0, 7. So 0, and then up to there. Oh, make that blue too. All right, so now it's still kind of hard to see what's going on here, right? Is this thing going like, this way, or is it going like, that way? Like what's going on here, right? One good little hint that I'd also do on this, or like right on this at the same time, is that if I look to my horizontal translation of 3 right, that's the only thing that's going to do anything to my asymptote, right? To my vertical asymptote. So you could draw that in too. So if it's going to be a horizontal translation of 3 right, then the asymptote also would be right here. It'd be at 3 as well. Let me make it black. So that's the line that it's approaching. And from that, I can kind of see, like I could even draw this in now, that what this is going to do is this, right? This thing is going to go like that and then start approaching this guy down here, right? But you could try out some more numbers, right? You could just keep throwing numbers in until you actually see exactly what that pattern would look like. So like really quickly, I'll do one more just to make sure that makes sense. Let's go, well, did I make another one? Yeah, let's do that one. So this point here was at, what was it, 9, 2. So 9, 2 would be at, so 9 plus 3. Don't need that bracket. Comma, and then the 2 would be 2 times 2 plus 5. So this would all turn into 12, comma, and then 2 times 2 is 4, so 9. So 12 comma 9. Okay, so does that make sense? Oh, negative. Oop, thank you. So that wouldn't be right. So that'd be negative 9 plus 3. That'd be negative 6, comma, and then 9. Okay, so that makes more sense. So if I was at now negative 6, so 1, 2, 3, 4, 5, 6, and then going up 9, then I'm going to be 1, 2, 3, 4, 5, 6. Okay, so that's where I'd be, right? So that's the right idea. So I knew that, you know, my original one was off a little bit there, right? But so it'd be more like that. There, and that's the idea, guys. I know this one can be a little bit time consuming, but once you get the hang of it, you'll get the right answer either way. And like I said, the other way of doing this was to actually like draw like a different graph every step in between. That's fine if you like doing it that way. The other video, like I'll leave that one up there too. Mr. Von Custer does it that way in the video. And if you like that way, then great, you can do it that way too. So yeah, I'll leave it there.